Okay, hi, so this is the past paper questions that go with lesson 8 in unit 9 and they're called initial rates PPQs in the lesson folder. That's what the document is called. So I'm going to take you through the calculation questions. I won't spend too much time on any of the others and just take you through some working. I'm going to go through the whole lot, so you may just want to skip forward to particular questions that you need help with and skip through the bits that you are fine with. So question 1 is determining the order of a reaction with respect to different things, D and E in this instance. So first of all, it says to find the order with respect to D and then order with respect to E. Now, actually, I'm going to start with E because it's a little more straightforward. The reason being that with D here, we have got 2 experiments where D remains constant. And so it's a good one then to select, if we select experiments 2 and 3 in order to calculate the order with respect to E, we can do that quite simply. So order with respect to E, if we see how much that's gone up by. So if we say what we're doing here, order with respect to E, so you can say 1.75 divided by 0.873 equals 2. So that is times 2, and then that to that, so the initial rate for experiments 2 to 3. So let's put that. So we can say 0.157 divided by 0. And please note the powers of that's minus 1, that's minus 2, so 0.0392 equals 4. Therefore, because 2 raised to the power of 2 equals 4, we can say that the order with respect to E is second. Okay, now the order with respect to D, there's nothing in any of the experiments, the concentration of E is never the same like it is here for D with 1.88, 1.88. So we're going to work it out slightly differently. And we're going to use here experiments, where are we? Experiments 1 and 3, because obviously these are the same, so we need to use either 1 or 2, 1 and 3. So I'm going to go 1 to 3 there. And that's going to be, 0.188 divided by 0.018 divided by 0.0125 gives you 1.5. Okay, if we then find by how much this is increased for E, okay, so if we say 1.75 divided by 0.581, that equals 3, okay? Now we know that the order with respect to E is second order. So the next step we're going to do, I'm going to put 1, 2, 3, is we're going to say 0.0116 times 3 to the power of 2. And that gives you 0.1044. Just FYI, I did these calculations earlier to check they work, so I'm not a mathematical genius at all. I already have some figures there that I'm referring to. So that gives us that. Now what we can then do is say this for experiment 3, so final step, 0.157 divided by the increase there, 0.1044, and that gives you 1.5. So we can see that when the concentration of D changed by 1.5 from experiment 1 to 3, so times 1.5, this also changed by 1.5 when you take into account the fact that E is a second order reaction. Okay, so D therefore is first order. Okay, right, so just why initial rates of reaction are used to determine these orders, well, because at the beginning that's the only time you know what the concentration is. After that you don't know, so yeah, I'm not going to do that bit, but that's essentially it. You can check the mark scheme. How the initial rate is obtained from a graph, well, you take the gradient at time equals 0. Again, you can look at the mark scheme for that. Right, question 2. Having a quick look, again, we're going to need to work out the order. So it says state how these data can be used to deduce the rate expression for the reaction between A and B. So rate expression is obviously going to be rate equals K, A, B, and what we need to then work out is what these are raised to. Okay, so the power that they're raised to obviously is the order of the reaction with respect to A or B. So let's have a look. Okay, we've got a similar situation here where for concentration of order of reaction with respect to A can be calculated quite straightforwardly because we've got sorry, yes darling.
Could you get me both the
Can you get your own?
No,
Yeah, go and get the stool and get it like a big girl.
Yeah, I can't on my lollipop.
Okay, right, I'm going to stop the video here and I'm going to do a new video for question 2.